Sorry. Looking at question 6, we're asked how many moles of silver are in a sample that has 3.612 times 10 to the 25th atoms of silver. Alright, so as always, writing down what we're starting with, 3.612 times 10 to the 25th silver atoms, and what we're asked for, where we're solving, or where we're trying to get to, moles, is really going to help us figure out what we need to do. So when we're looking at moles, there are two possible conversion factors. Molar mass, when we're converting between mass and mole of the same chemical, and Avogadro's number, when we're converting between number of particles, such as atoms or molecules, and moles of the same chemical. So here we're given silver atoms. That's not a mass, that's a number of actual particles, and we want moles. So once we identify whether we're converting between moles and mass or between number of particles and moles, then we'll know which conversion factor to use. So here is Avogadro's number, always the same. 1 mole of the chemical is equal to 6.022 times 10 to the 23 of the particles that make it up. So in this case, it's an element, a metallic element, and so it's atoms. So we do the conversion as we do all of our other conversions. We take our given value and we multiply by the conversion factor, which is the equality in ratio form, such that the unwanted units cancel out. So it's 1 mole of silver over 6.022 times 10 to the 23rd silver atoms. So our atoms of silver cancel out. Now, one problem that people have is with using their scientific calculator. So we look at this online version, and I'm going to put in 3.612. Now the times 10 is just the exponent key, or the EE key. You don't hit times exponent, you don't hit times 10 exponent, you just hit the exponent key, or the EE key, after you put this decimal part in. So 3.612 EE or EXP, and then the exponent, and then divided by 6.022, and then the EE key or the EXP key. You don't hit times EE, you don't hit times EXP, just EE 23rd. And then that equals 59.98, and the question asked us to express it to the 100th place, so that's why it's 59.98. So does that make sense? Well, a mole is 6.022 times 10 to the 23 silver atoms, and our original value is much larger than that. It's 10 to the 25th, and so that's 2 orders of magnitude. So yeah, this answer makes sense. We would expect to have more than 1 mole of our substance given this amount of atoms that is way larger than a mole, or 6.022 times 10 to the 23rd. So there are lots of practice problems online. I highly encourage you to look at those, and I hope this helps.